Okay, good morning, middle one. Hope you are okay, inshallah. Let's start our first lesson in algebra, which is a revision about Junior 5 and Junior 6. What is the meaning of a set? A set, it's a group of things that has a common properties. You have the common property, which means you have the common things. Okay, we took in Junior 5 the set of numbers. You remember, set of counting numbers. Okay, what is the meaning of a set of counting number? It's a set of whole numbers. We start with 1, 2, 3, 4 and so on. It's an infinite set. Do you remember? It's an infinite set. Okay, how about the set of natural numbers? Natural numbers, we start, they are whole numbers, but here we start with a 0 because the 0 here should be a whole number inside the natural number. But why we didn't put inside the counting? Because the 0 is not a counting number. And then we go in Junior 6 and we took a set of integers. Do you remember the set of integers? Let's remember it with a drawing. Set of integers, we have z. Inside it's z negative and the set of 0 and z positive. What's inside z negative? We start with what? Braces. We have braces. -1, -2, -3 and so on. We can't say 0 because the 0 is neither positive nor negative. How about the set positive? We say here that positive we start with 1, 2, 3, 4 and so on. So this is an infinite set and this is an infinite set. That positive, which means counting. Both of them are the same. We start with 1, 2, 3, 4 and here we start with 1, 2, 3, 4. 0, I can't put it inside that negative and that positive because 0 is neither positive nor negative. If you remember when you draw the number line, you remember the number line in Junior 6, we put here in the middle 0 because 0 is neither positive nor negative. The left side here is the z negative, so we start with -1, -2 and so on. And the right side here is the z positive, we start with 1, 2 and so on. This is our number line and this is our circles that we took it in Junior 6. Okay, this is the sets that we have taken before, which are set of counting, set of natural, set of integers. What we are going to take this year is a set of a rational number. Our first lesson is a set of rational number. What is the meaning of a rational number? It is a number that can be expressed. We can make it in the form of a over b, where a and b are integers and b not equal 0. So the first condition, you should note that it is a number in the form of a over b. This is the first condition in order to say this is a rational number. Second condition, b not equal 0. Okay, let's take an example. So here, what's the meaning of a over b? X over y, L over m, n over o, whatever. Any letters, I can assume any number up and any number down, but they should be integers. So it should be positive or negative. So we can say, for example, let's see down كده. We have 2 over 7, this is a rational number. -3 over 5, this is a rational number. 8, which means 8 over 1. 0 over 6, fine, which means equal 0. 2, which means 2 over 1. 0.75, which means if we change it into a decimal and a fraction, both of them are the same. So it will be 75 over 100. 35%, what did we take in Junior 6? We said when we want to get away the percentage, we should write it 35 over 100. So all of these examples are rational numbers. This is the first thing. Second condition, we said that b not equal 0. What's the meaning of b not equal 0? This means down I can't put 0. For example, I can say 0 over 2. What's the meaning of 0 over 2? Which means 0 divided 2, which means the answer 0. But if we say 2 over 0, no answer. No, which means meaningless. Meaningless or error. We can say 2 divided 0. We can't say 2 divided 0. So the first condition, it should be in the form of a over b, x over y, L over m, integer divided integer, or in the form of a numerator over denominator. So first of all, q equal x, such that x equal a over b, numerator and denominator. A and b belong to z, so positive or negative, except the 0. We can put the 0 up. We can put the 0 up, but we can't put the 0 down, okay? So let's take our notice here. Number divided 0, meaningless, but 0 divided any number equals 0. For example, 0 over 7 equals 0, but the 7 over 0 has no meaning.